So we're into naming now, naming of molecular and ionic compounds. And it's kind of like those archaeologists up there, right? They look at this, I mean, what the heck does it even say? Or these other folks down here, I like this bottom one. This is the name of their committee. An essential subcommittee steering group for the facilitation of brevity and clarity of language usage in the... It's not short, and it's not clear. So, kind of funny. But the whole point of this is so that when you say carbon dioxide, or you know, the guy on the halfway across the world you're texting says carbon dioxide, everyone understands what everyone else is talking about. That's the whole point of this. So we need to be consistent with naming these compounds. And, oh, hey, let's see if we can catch this right off the bat. Ashlyn, what's the difference between a molecular compound and an ionic compound? Yeah, you have charges on stuff with ionic compounds, and they're sticking together.
And then molecular, I guess, would be just a compound that formed without changing charges.
Oh, that's perfect, right? So you have some stuff that forms with no charges involved at all, right? That's going to be these little molecules flying around. Then she said you've got ionic compounds, things that have different charges, and they get stuck together. Now, the things that have the different charges, they get stuck together. They're not going to be little molecules flying around. They just keep getting stuck together, stuck together, stuck together. You make huge crystals out of the stuff. And the more stuff you stick together, the bigger the crystal, right? You can take a hammer and lop some off. Can't do that with a molecular compound. I guess you could. A molecular compound is going to be there, and you can take a hammer. But it's still molecules. You can't bust up the molecules. Okay. So that's kind of the idea. And we're going to have different rules for naming the ionic compounds versus the molecular, and you'll see. So let's first start talking about the ions. And Ashlyn kind of helped you out there, Taylor, but what's an ion? Some little... Anybody help her? Yeah, a little charged particle. Good enough, right? So all those elements on the periodic table, you just rip off somewhat, and you can change its charge. What do you have to remove? And we haven't really got into this yet, but the electrons, right? You rip off the electrons, and then it's going to be charged. But you don't have to rip off the electrons. You could also add some electrons and have it have too many, and then it's going to have a charge. Now, if it has too many, it would be positive or negative. Negative. We're getting like a chapter 3 ahead. That's fine. Rip off some electrons, then it'll be positive. So that's kind of where we're headed here. All the metals on a periodic table. Yvette, I want to draw a big circle on this periodic table here. Where are the metals? In the middle? Oh yeah, there's a bunch of metals here. I'll be circling this stuff. Do I keep going to the right? Yeah, I got all that stuff to the left. But you're right, only I have to stop somewhere. And you can hardly see it. Can you see this bloody thing? All right. Kind of like there. All right. Yeah, there's a name for them. Yeah, kind of like metal and... Yeah, kind of... Well, not really gas. Better word than gas. Non-metal, I guess. All right. But anyway, she just kind of told us where are the non-metals then. So if these are all the metals, right? And then all the non-metals over here. Okay. Now it's really helpful to know that because it's going to help us on several aspects here. When it comes to ions, metals always form positively charged ions. Now there's a name for it though, Victoria. Positively charged ions. What's it called? Cations. All right. And then Paulina, nonmetals, anions. They're always going to be negative. If they have to be an ion, they're going to be negative, those nonmetals. Okay. Maybe we call them anions. So that's going to be really helpful when you start, I think, recognizing and writing ions and figuring out what they are and naming them. What are the possible charges, all that kind of stuff. What are the possible charges. So some helpful hints for memorizing names of cations. I don't like this word memorizing, but we really don't have any other choice because it's convention, right? It's like that sketch here. These guys have to memorize what the heck this stuff means. We are going to be learning Greek, if you know what's coming. If you've been exposed to this before, we are going to have to learn some Greek, but that's just how life is, I guess. Okay. Elements of 1A. Now, right off the bat, 1A, right here, right? 1A. They can only have a charge of positive or negative first. Positive, because they're a metal, and it's just 1. Right, positive 1. So if you want to write, thank you very much. So if you want to write sodium, it's ion. That's how you'd name sodium. And that's also how you'd name its ion, sodium. And the reason why is because it has to be +1. We don't have to say sodium 1. Because remember, the scientists, they like to write the minimum necessary. So they're never going to write sodium with little parentheses and put a 1 in there because it has to be 1. So it's just sodium. So Na plus has the same name as Na. 2A. Group 2A, Desiree. Right next to it, 2A. Desiree can only have a charge of, just guessing, +2. So the element magnesium, or its charge, have the same, or with its ion, have the same name. Magnesium, magnesium. Mg +2, magnesium again, because it has to be +2. Okay. Everything else, all these other metals, all these group Bs. Remember how we said I kind of hinted, I don't know if you remember, but we had the main group and we had the transition. The main were the ones with the A. The A are going to have a fixed charge no matter what. The Bs pretty much take on whatever they want. So that's why we have to kind of change the rules for these group B metals, like group B elements. So all this stuff in here, all those transition metals. You give the name and the charge in parentheses for writing these ions. And again, they're metals, they have to be plus. So what's iron? Jessica, what's iron? What was iron? What was it? Anybody help her? What was iron? Fe. All right? So that's how if you say iron, you're just talking about this, no charge. But if you say iron 3, you're talking about that. Okay. And there's one other common cation. So this is pretty much all the cations. Covers all the rules for everything. Everything in group 1, 1A, has a +1. Everything in group 2A has a +2. Everything else, you have to give its name and its charge in parentheses. Except this dude, ammonium. It's our first polyatomic ion. It's more than one element stuck together. You got to memorize it. You got to know the charge. Does anybody know what it is? NH4+. Ammonium. Ammonium. Okay. So that takes care of all the cations, for the most part. Now we've got some anions. The negatively charged stuff. Now, if you remember the trick, it's not so bad. First off, man, there's not much of this periodic table left to worry about. It's just these guys, remember? And remember, the nobles don't do anything really, so we're not even really worried about them. We're just worried about all those guys. So there's not too many to worry about. And if you just remember 8 minus the group number, that's how we're going to get the charge. And then we're going to add an IDE. For example, if you have F, what do you call that? Oh, here's a good one. How do you spell this? How do you spell fluorine? F-L-U. Flu. I always remember fluorine. So there's a U in there. And then fluor. Then I don't have a charge on it. So just fluorine. Now it doesn't have any choice. What's the group number for F? Yeah, it's that Roman numeral 7 up there. 8 minus 7 is 1. So that means F can only have a charge of a 1. But remember, they're all anions. So it's not plus 1, it has to be negative 1. And then how are you supposed to name it? Fluoride. So you can always take 8 minus the group number, right? Or just count over to the nobles. For me, counting over to the nobles is faster than doing math. For example, if you have N, when I write its ion, right? You could count over to the nobles. Find N. Where's my little laser pointer? Find N. There it is. And just count over to the nobles. 1, 2, 3. So it has to be a negative 3. But if you like the math thing, take 8 minus 5, get 3. Seems like it's more steps. I don't know. It's up to you, right? But anyway, this guy would be called nitride. Right? Let's see if you're following me. How about Gloria? How about carbon? What ion would it form? C, negative 4. Perfect. And then how would you name it, Brianna? How would you name it? Exactly. And this doesn't sound weird? You said it. You said it. Carbide. All right. Carbide. So you can mess with a lot of these. Carbide, nitride, oxide, fluoride, chloride, sulfide, right? Just add ides. It's not too bad. Okay, now this is where, to me, it's been okay so far. You know, okay, I can see all this. I have to laugh because I remembered looking at that. What the? Look at these things. These are coming out of nowhere. But this is nature. And we just have to know them. Right? These are all these polyatomic ions. Some are positive, but almost all of them are negative. So that's kind of a hint when you start memorizing this stuff. They almost all have a negative charge, except for that ammonium. And this mercury 1, you're hardly ever going to see it anyway. But we have to know the names and formulas of all this stuff. Okay? Well, that's coming up. I'm going to tell you. I might as well tell you now. You're going to have to know the names and formulas of it all. But it's going to be, making these ionic compounds is going to be just what, I forget who said, someone said, Ashland maybe? You just combine these anions with cations, and then we're going to be making stuff. Okay? But we have to know how to write hypochlorite, right? For example, that it's ClO negative. And then this is kind of where we're heading. Okay, and then we're going to put sodium in front, right? And learn how to write these compounds and stuff. But that'd be sodium hypochlorite. But anyway, we need to know the parts before we can start putting together the puzzle. So we need to know the names and formulas of all that stuff. Naming ionic compounds. Oh, here it is. So when we start naming these ionic compounds, you always list the positive cation first, and then you put the anion. For example, calcium chloride. What would be the formula? So here's an ionic compound, calcium chloride. Whatever's listed first is always the cation. It's always positive. Whatever's listed last is always the anion. What would be the formula? Stephanie, what are the ions that make up calcium chloride? Now the calcium, take your time on it. Now the calcium is what symbol? Ca. Okay. Now we have to write down its charge too, though. Because what are the ions that make this calcium chloride? Its charge would be what? I think you said it. Someone did. It has to be positive 2, right? Because it's in group 2. Another hint is that you don't see any Roman numerals there. No parentheses with Roman numerals. So that means it's got to be +1 or +2. It has to be. You just have to look on the periodic table to see which one it is. So it has to be +2. Okay. The chloride, Christina. What ion is that going to be? Cl. Okay. Well, you can say 8 minus 7, or do the thing where you count over to the nobles. 1, but they're always positive or negative? Negative. Another hint is whatever's listed second, these guys are always the anions, always negative, always positive. That's another clue.
So calcium is +2 because it's in group 2?
Exactly. And a hint to look at the periodic table is, there's no Roman numerals written there, right? And there's no parentheses with anything. So you got to look at the periodic table to figure it out. Okay. Now there's one last trick to writing this. There's something wrong with it. Does anyone see what's wrong with it? If you touch this, you get a shock because it's not neutral. You grab a bottle of calcium chloride or any compound, you don't feel zzz, right? It has to be neutral. So what can you do to make this thing neutral? Cross the charges. Why do math, man? Do that diagonal thing, right? Cross the charges. You hear what she said? Put the 2 down here, put the 1 down there. I like that. You got to remember that. Cross the charges. That's good. Right? And now do you see why it works? Because now I have 1 calcium for every how many chlorines? Or how many chlorides? 2. That's what those little subscripts mean. So I have 1 calcium, that is a +2. I have 2 chlorides, well, they add up to be a -2. So it's just the simplest ratio. So you can write it like this, or you can write it as CaCl2, or you could write it as CaCl2. A lot of people, this is going to be the most common though, because no one ever writes the little 1s. But we're just starting out, so it's fine. Okay. So you can write it with the charges in there, or it's just important to have that ratio of 1 to 2 in there. Okay. So this is the game plan, Gloriana, for naming ionic compounds, for naming crystals, for naming stuff where a plus and a minus is what's holding it together. Okay, this is the game plan to do that. Now you always follow this game plan when you see a what? It's not an easy question.
I'm right here.
Go ahead. Does anybody know? When you see a what? Well, charge would be a good point, yeah. But a metal. If you ever see a metal, and the metal's most everything up there, right? So it doesn't matter. If you see a metal somewhere in this compound, it has to be ionic. Okay? If you ever see a metal. So when we start talking about molecular compounds, there can't be any what there then? Metals. There can't be any metals. So now we're going to, I said Greek. Now when we start this whole new naming method, this whole new strategy, you follow it when you don't see any metals. Right? There aren't any metals. It must be molecular. It must mean literally like water, man. Little tiny molecules flying around. That's what makes it up. Not crystals anymore. Not pluses and minuses. There's no metals present. Okay. We have to count to 10 in Greek. We have to count to 10 in Greek. Marco, how do you do that? Does anybody know? How do you count to 10 in Greek? What? 1 is mono. Somebody knows some of this. 1 is mono. 2 is, I should start writing this down. 1 is mono. 2 is di. 3, tri. Now, where does this, we must have been around here somewhere. I don't know where you encounter this, right? But it's there, because you guys are saying it. What's 4? Maybe in geometry, like triangle, right, and stuff. 4 is tetra. 5 is, it is geometry, isn't it? Because it's pentagon. 5 is penta. 6, hexagon, hexa. I bet that's why this is sounding familiar. 7 is heptagon. Not very common though. 8, octa. Octagon? Isn't that the shape of our security place there in Washington? 9, nana. Dang, she already knows her Greek. Nona. And 10 is the last one we need to know. Deca. Mono, di, tri, tetra, penta, hexa, hepta, octa, nona, deca. We have to know how to count to 10 in Greek. Otherwise, we can't name this stuff. We can't name it. Because what are the rules? The rules are, first, you can't see a what? In this formula, you can't see a what? A metal. If you don't see a metal, use the Greek stuff. Okay, so what does the Greek stuff say? It says, first, let's see, name the first element and add IDE to the second element. And use Greek prefixes to indicate the number of each element in the molecule. So in this molecule of SO2, how many molecules of S do we have? There's just one. So that means we have to use what prefix? Mono. So you're going to start out with mono. Now we only add the ide to the second element. So that means we have to name S for what it is. S is sulfur. So we have monosulfur. Okay. Now we have to say how many oxygens yet. Well, you knew O was oxygen anyway. There's 2, so that has to be di. Oh, you already said it. You don't say oxygen, you're supposed to say oxide. Okay. And to make life a little more confusing, they very commonly, you're going to see it. Instead of saying monosulfur dioxide, you might hear it as what? Sulfur dioxide. They sometimes drop off the mono. It's just like this. This stuff kills you if you keep your garage door open, or garage door closed, and you start the car. Carbon monoxide, right? Technically, it should be what carbon? Monocarbon monoxide. Technically, that's the correct name. But all right, let's see if you're following me here. P4O5. I added some. I don't think they're in your notes. P4O5. Bianca. P4O5. Where's Bianca? Bianca. P4. So you have to start out with the Greek guy. How many phosphoruses there are? What's 4? 4 is tetra. All right, now, Maria, you've got the the real easy part, spelling this. What's P? Where's B? Who did I just pick on? Bianca? Oh, Maria. Sorry, Maria. What was P? What was the name of it? P was... Anybody help her? Phosphorus, but you got to spell it, right? And there's no F's, that's a hint. pH is tetra, phos, for, us. All right? So we're at tetraphosphorus. Adelpho, what'd you do next? Tetraphosphorus. Penta. And Janet? So you've got most of it. There's the tetraphosphorus, penta, the O part, oxide. Okay? And you might see them, if you've seen this before, they might drop the what on you? I think maybe just because it's easier to say. I don't know why. But they might drop the little A. But technically, this is the way you're supposed to say it. Tetraphosphorus pentaoxide. But sometimes they drop that little A, so it'd be tetraphosphorus pentoxide. But it's the same thing. This is technically correct. So don't think they misspell it. So what's the technical way to say water, Erica? What's the technically correct way to say water? Keep going. Dihydrogen. Keep going. Ooh, oxide. Now, there's another thing we didn't mention. You can say dihydrogen oxide. She dropped off the mono part. So that's perfectly fine. But dihydrogen monoxide is probably, the top-notch way to say it. But this is perfectly acceptable, what she said, because they sometimes drop that mono. Dihydrogen monoxide. Okay. Oh my goodness, right? Know the names and symbols of all the elements in the first 4 periods of the periodic table. Right? We were asked that a little while ago, but we're probably still working on it. Know the names and formulas of all ions, including polyatomic ions. So those polyatomic ions was all this stuff. Oof. Still getting piled on. Know how to name ionic and molecular compounds. Right? The ionic is one where there's a metal present. You name the cation, then the anion. The molecular, you got to count in Greek. Add IDE to the end. So we're going to have naming on every single quiz up to the first exam. Now the first quiz, you can use a cheat sheet. So I don't care what you write. Don't write on yourself. I mean, it's a cheat sheet, so use whatever you want, right? So my suggestion is you're going through and you're naming all this stuff. Probably say it out loud because things go faster, right? Cover a piece of paper. And if you're studying, another thing that works for memorizing, you're starting at the top. And then you keep, you have the first 3 memorized, you screw up on the 4th one, you go back up to the top again. And then you keep going down, right? That's the quickest way to memorize really anything. You cover stuff up, and you keep going until you screw up. And when you screw up, you go back to the beginning again. Okay? Now, if you have the flashcards, the ones you don't throw them out. Keep them in that pile. You get to know them even better. Okay? So that first one we can use a cheat sheet on. So let's play around with this some. So we want to name whatever is written in this column. We want to give the name of it. Okay, it's just K. So Christian. Potassium. Now let's just keep going. Potassium. Christian. Jacqueline. Yeah, that's where we stop. She's right. Don't say potassium 1 or anything. And why not? Why don't we say potassium parentheses 1? It's too long, yeah. It's in group 1, right? It's fixed. It has no choice. Everything in group 2 is always plus 2. Oh, so that kind of covers these 2 then. How about, let's jump down to I minus. I minus. Yosenia. I minus. Anybody help her? Iodide. Iodide. Because it was iodide. Yeah, that's how you spell it. It was iodine, so it's iodide. How about Ashlyn? Cu. Copper. Taylor. Next one. You're right so far. Keep going. Copper. So the only thing you need to check, Taylor, is that copper, use the periodic table. It's your guide. Is that copper in group 1 or 2? It's not. So that means you have to give its charge in parentheses. So what's its charge? In parentheses, write a Roman numeral number 2. It has to be Roman numeral 2. You can't write the number 2. They want Roman numerals. Okay. How about this one? This is a trick question. There aren't very many of these, but this is a trick question. Victoria. You got the trick question. Al plus 3. Yeah, how did you know that? Victoria was supposed to say, according to our little rules, you look for in group 1 or 2. It's not there, so you're supposed to write this, right? According to our little rules. But aluminum is one of those, it's a very rare metal. It and zinc, they're right next to each other diagonally. They don't have a choice. Aluminum is only plus 3, so it's just Al. Because anything where it doesn't have a choice, you don't ever give it its charge in parentheses. So that and zinc, you don't give the charge in parentheses. They're kind of the trick questions. Okay. Ah, there it was. Okay. Let's try 11. Paulina. Number 11 there. Ag plus. Yeah, the name. What's Ag? Anybody help her? Silver. Okay. Do we just write silver, or do we have to write its charge in parentheses? Charge in parentheses. So you'd write silver, just a 1, right? Because it's just a plus. It would be nice if they would write 1s on this stuff, but they never do, right? If you see a plus, it means a plus 1. If you see a minus, it means a minus 1. Sulfide. Lauren, sulfide. Okay, good. Man, you're halfway there. 2. Yeah, and it's 2 because she's counting over to the nobles. And is it going to be a positive or a negative 2? It has to be negative, right? Because all those nonmetals, they're always negative. You should figure it out. So to me, that's kind of easier. When you can figure stuff out and use logic, it's a lot less to memorize, right? Oxide. Desiree, oxide. O, negative 2. All right, now they're starting to get ugly, Jessica. Carbonate. Man, right now you'd probably have to use the table because you had never seen this stuff before. Unless you've got it memorized already. It'd be nice to have one of those photographic memories. Just look at it, boom. What is carbonate? Yeah, let's see something. You already got half of it memorized. There's a 3 in there. It's a CO. It's a CO3. And you got to know that's negative 2. It's just right out of that table. Gloria Morales. How about SO4 with a -2? What is that one called? Sulfate. Yeah, right from that table. Man, if you can name this thing 16, you are really on track here, Brianna. This is the tip of the peak here. How would you name that? Oh man, she's halfway there already. Calcium. Remember, this is just like the quiz. You can use your cheat sheet, use the tables and stuff. Yeah, it's in that table. You said it. I think she said hydroxide. Right? Because she found OH negative in that table. And so all she did is she named this ion, and then she named that ion. That's all she did. Now, let's try to screw you up here a little bit. Why? This is right. Why did what's wrong with writing calcium in parentheses 2 hydroxide? What's wrong with writing that? Well, we'll get to that one. But what's wrong with writing calcium in parentheses 2 hydroxide? There's only one calcium. Calcium has no choice, right? It's in that group 2. So calcium, everything in group 2 has to be plus 2. In fact, anything, there's another hint, anything with the A, the main groups, if you see it in there, it has no choice. It has to be that charge. Anything with a B, then you put the charge in parentheses. Except for those 2 trick questions. What were those 2 metals? Zinc and aluminum, right? So there's kind of a trick to that, but just remember everything in the group B has transition metals. Oh, let's do that last thing I can screw you up with. What's wrong with writing monocalcium dihydroxide? What's wrong with writing? You see a metal. You see a metal. So this isn't a molecule. That's what's wrong with it. Okay. And whenever you see these polyatomics, that's another kind of hint. Whenever you see these polyatomics, they all have charges. They can't be molecules then, because molecules are stuff just stuck together. Okay, you probably have time for one more. Calcium phosphate. Now we have to write its formula. Stephanie. Last one. Okay, she's got the Ca. Good. Okay, she's reading, right? You got that chart. So PO, -3. And on that PO, it's a little subscript on the O is 4. Okay. We're really, really close. What she's skipping, someone said it. Who said it? What should say? Cross the charges, right? Well, let's write the charge on the calcium so we can cross the charges. What's the charge on the calcium again? +2. So now let's cross the charges. The 3 goes down there. The 2 goes down there. But we're probably missing what? To be more clear. What does that mean? A 4? Then a 4 has a subscript of a 2? No. Put the parentheses. Put the parentheses around these polyatomics. See how they did it? They put the 2, because they did the crossing. The 2 went down there, and the 1 went down there. So the 2 goes down there, the 3 goes down there, and do those. I say always put parentheses around polyatomic ions. It's just easier to see it.
Do we have to erase the numbers out loud?
You can if you want to make it look neater, but I kind of like it there, because then if you're trying to explain it to the Joe next to you, look, this is how I got it. Okay. So, man, aren't you going to have a fun weekend? So, thanks for being so attentive.